Welcome to another exercise for this workbook, Statistics. This time focusing on measures of association and in particular on the covariance and correlation. So let's have a look at the exercise. Here we have 5 visitors of an amusement park. We collected time spent in the park in hours as well as the age of the visitors, resulting in the following data set. So here, the two series of data, the 5 observations. Our task now, calculate the correlation coefficient by Pearson. Well, officially it said it's about correlation and covariance, but we're going to need the covariance in either case if we're going to calculate the correlation coefficient by Pearson or Brevet Pearson. Well, how are we going to go about this? First, going to copy this table here, and I'm going to name the two variables. I'm naming them x and y. In this case, it's just arbitrary because correlation doesn't imply any kind of direction. So here I could name any of them x or y. So I'm going to add then to this table another row where I'm going to square all the x values. So 2 squared, 10 squared, 12 squared, 6 squared, 9 squared. Going to add an additional row where I'm going to square all the y values. So 32 squared, 23 squared, 32 squared, and so forth. And finally, I'm going to add one final row where I'm going to multiply x and y values. So 2 times 32, 10 times 23, 12 times 32, and so forth. That's just intermediate work, which I need to do because I'm really interested in the last 2 additional columns. Well, I could sum up all these values and then I'm going to divide them by the number of observations because that's actually the most important part. Of all of these 5 rows, I'm going to need the average. And well, x and y I already have, so I could divide all these values by 5. Here, well, I could write all of this stuff down, or I could simply just take the values, square them, add them up, calculate the average, because those values, they're just preliminary work. I'm really just interested in the average of those values, the average of those values, and the average of those values, or rather, the sum divided by the 5 observations, sum divided by 5 observations, sum divided by 5 observations. That's all the 5 values I need for the covariance and the correlation coefficient. So if I start with the formula, I have actually here a fraction, and what I see in the upper part, above the fraction line, that's my covariance. And that's nothing else than the average of x times y. Well, average of x times y, that's our last column, last row. It's a 214.2 minus the average of x times the average of y. So that's 7.8, 28.6. If I calculate the upper part, that's my covariance. Then I'm going to divide all of this by the standard deviation of x and the standard deviation of y. Here I can most easily do this by simply going the average of x squared, that's what I did here, 73, minus the average of x, 7.8 squared, that's this part, and then taking the square root thereof. I'm doing the same thing for y, so I'm going to take the average of y squared, 861.4, that part, minus the average of y, 28.6 to power of 2, subtract this, get the square root, giving me the standard deviation of y. Well, if I plug in all the values, it looks like this. I'm going to put this in my calculator and I get a result of minus 0.1108. Well, first off, I see this is a negative relation between those two. So younger people spend more time in the park. I also see that it's a relatively weak relation because we can make like threshold values at 0.1, 0.3, 0.5. If it's smaller than 0.1, absolutely speaking, there's no relation at all. Well, this is slightly larger than 0.1, so this is a very weak negative relation. Well, that's also what we can use if you want to check whether you did everything correct. On the one hand, only the upper part, only the covariance can be negative. Those are square roots, they will always be positive. Again, the correlation coefficient can be positive, can be negative, but it will always be between -1 and +1. So if you get something else, something must have gone wrong. Also, if you just want to check whether you did work decently well, you could just take a look. If I have the averages here, take a look whether they actually are somewhere between those values listed here. So there need to be values larger and values smaller than those averages. If you didn't actually fill in this part here, well, you might check simply x squared and compare this with this value here. They will never, well, usually not be the same, but they should be in the same size. So if I square this, this will be somewhere around 60, maybe slightly smaller than 60. That's not 73, but it's in the same direction. If I would square this and I would get like 2, and here 73, that would be an indicator that I might be really off with one of those two. And then I would just check again whether I made some errors at this point. Well, that's then already everything there is to this exercise. So I hope you enjoyed it. I say goodbye and see you next time.